So in today's class, we are going to discuss about variable length subnet mask. So already we have completed our discussion about the IP addressing. We know that there are 5 classes of IP. In that we have class A, class B, and class C, which we are using for the normal addressing techniques. And we have already completed discussion about the subnetting. So in today's class, we will concentrate on variable length subnet mask, and we will also discuss what is the need for variable length subnet mask. So to start our discussion, let's have an example network. So we'll have a network like there are 3 routers. And let's say this network needs 25 hosts, and this network needs 12 hosts, and this network needs 30 hosts. All right. And how many networks do we have in this particular topology? If we see how many networks we have, say this is, let's take this as network 1. And there are 2 IP requirement here. So let us take this as network 2, network 3, this is network 4, and this is network 5. So by a normal subnetting, all right, so we understood that the maximum host that is required is 30. So let's take a class C IP address. It is given that 192.168.1.0/24 is the IP given to us. And as a network administrator, you were asked to assign IP for all the networks using this single IP address. All right. In that case, you will obviously go for subnetting. So let me expand the last octet. This octet I would like to expand. So I just expand in the 8 bits. So the maximum requirement is 30 hosts. So we know that 2 to the power of 5 is 32. All right. So at least I should have 1, 2, 3, 4, 5 bits, which is left out for the host bits. All right. So I wish to borrow 3 bits to the network portion. All right. So let me borrow 3 bits to the network portion. So now if I borrow 3 bits to the network portion, the /24 will become /27. All right. So it will become /27. And the range of IP, if suppose I want to write the range of IP, it will be 000, 001, 010, 011, and 100, 101, and 110, and 111. So this is the IP that I'll get. If I write the first IP and last IP, I'll get as 0 to 31. So I'll get 32 to 63. Then we'll get 64 to 95, and 96 to 127, 128 to 157. And then I'll get 160 to 191, so and so on. So let me assign this to the first network, this to the second, this to the third, and this to the fourth, and to the fifth. All right. So this was a class full addressing. Okay. So what I have done now was called as the class full subnetting. All right. What is that class full subnetting? All the networks will have the same subnet mask. Okay, I have divided, but what is the problem? What is the trouble with this type of addressing is, we understood that here it is okay that I'll get 30 IP addresses apart from the network address and the broadcast address. But here again, I'll get 30, but what is my requirement is only 2. So 28 of my IP address is wasted, right? And similarly here I'll get I need 25, but 5 address is wasted. Similarly here again, I need only 2, but 28 is wasted. So you could understand that the IP requirement is variable, and most of the IP addresses are getting wasted in the class full subnetting. So we go for an option called a class less subnetting. Okay, or you call this VLSM. All right, so variable length subnet masking. So variable length subnet masking is nothing but based on your requirement, you are going to subnet it. right? So let us understand how this is done. From this example scenario. Yes. So let me take the same scenario, enable my pen. So let us take the same scenario where I'll have the 3 hosts. So this is the first router where the network connected to this need 25 host. And then here I have one more router, and this needs 30 host. And here again, I have connected one more router, which needs 12 host. So the requirement, let me write it as this is a network A, all right, a network B, this is network C, this is network D, and this is network E. All right, so if you have your VLSM workbook, you can even turn to page number 3 where this concept is explained using some box. All right, right. Let's take A, B, C, D, and E. All right. And so what I wish is I need a 30. So as usual, I'm going to borrow 3 bits. Okay. And I'm just getting the first network 0, 0, 0, 0, 0, 0, 0, 0, right? /27. So the rest all you can write it as 192.168.1. The last of it I have split it like this. So the first, this is the first IP, which is the network address. So if I want to write the last IP, I'll write 000 and 11111/27. So in between, I'll get IP from 1 to 30. All right, yeah, 30, 1 to 30. So I get 30 host. So this box, okay, this box, I wish to assign it to the network A. All right, because already I've got 30 IPs. So what is the next requirement? So this is done. All right, so this you need a 30 address, then 2, then I need 25, again a 2 and a 12. So this is done. Okay, this block assignment is done. So the next block, let me come to the next block. It is 0, 0, 1, 0, 0, 0, 0, 0, right? So /27. So now when I take this, again, I need at least 25 hosts. So what I do is I'm going to write the last IP, which is 001 1/27. So if I write the values which is in between, it is something 3 to 62, right? So 33 to 62. So what I'm going to do here is let me assign this box. Okay, again, this box I wish to assign to C. All right, I wish to assign to C. So this requirement is also done. So the next requirement, in order to give the next requirement, I just take the next block. Okay, so already we have a lot of blocks 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Okay, so now all these 2 blocks done. So I'm going to take this block. Okay, so this block is 0, 1, 0, 0, 0, 0, 0, 0, right? /27 is already there. Now, if suppose I'm taking this and giving to network E, I feel that 15, at least 15 of the IP address is wasted, right? So now what I'm going to do is let me just split this again into 2. All right, this network, I wish to split it into 2. And I just take 0, 1, 0. I'm not supposed to touch it because already I have borrowed it. This octet, okay, this octet, it is 0, 0, 0, 0, 0. And the new prefix will become /28 because the subnetted one, still I'm subnetting it. All right, so already this is a subnetted one, but it is in /27. So by borrowing one more bit to this side, I have splitted this into 2 networks. So this is called as first block. And in that, again, the second block is created as 0, 1, 0, 1 0 0 0 0 slash 28. Okay. So this is how I have splitted it. Now, if I write this in decimal, okay, if I write this in decimal, I'll get it as 64. Okay. And what will be the last IP? Last IP will be nothing but 0 1 0 0 1 1 1 1. All right. So the last IP is nothing but it is 79. Okay. If you write this in decimal, you will get it as 79. So this block 64 to 79, let me assign to E. Right. I have assigned it to E. Right. So now this box. So E assignment is also done. Okay. Fine. Then let's take this. Okay. Let's take this. What is the next requirement? Next requirement is only 2. Okay. So next requirement is only 2 means I can it's enough that I have only 2 bits left for the host. So these 2 more bits also I can borrow for the network side. So what I'll get here is, let me explain this again. 0 1 0 1 0 0 0 0 slash 30. Okay. Then I'll get 0 1 0 1. Okay. So 0 1 0 0 slash 30. Right. So similarly, I'll get 1 0 and 1 1. Okay. So this one I just assigned for the B network, and this one I just assigned for the D network. All right. This one for B and this one for D. So what is the main advantage? If you see that workbook, you could understand what is the main advantage. We were able to save so much of address space. Okay. We were able to save so much of address space. Fine. So let me explain with one more example so that you can understand that better. So I want all of you to turn to page number 6. Okay, so page number 6, where they are explaining again with the box method. We will just explain. We'll just see that. All right. So in this, the topology says you have a router where this part of the router is you need 60 hosts. All right. And this part of the router, you need 28 hosts. All right, 60 host and the 28 host. So this is problem number 1 in page number 6 of the workbook. Right. So 60 and 28, and the IP that is assigned is 220.10.0.0. Okay, so find out. Let me say this is network A and this is network B. All right, so network A's requirement is 60 and network B requirement is 28. All right. Now let us take the whole IP assignment as 220.10.0.0. So what is the maximum requirement? 60. All right. So in order to get 60 host, so usually we will borrow 2 bits. Okay. So why 2 bits? Because let me expand the last octet. So if I expand the last octet 1 2 0 4 5 6 7 8, at least I need 1 2 3 4 5 6 bits. Okay, to get 60 host. 60 host வேணும்னா at least நமக்கு இங்க 6 bits ஆது இருக்கணும். So I can borrow only 2 bits. Right. So if I borrow 2 bits, I'll get 4 networks. Right. So let me put it in the form of a box. So if I put it in the form of a box, I'll get 4 networks. So let's say this is 0 0 0 0 0 0 0 0. This is 0 1 0 0 0 0 0 0. This is 1 0 0 0 0 0 0 0. All are slash 26. Okay, slash 26 slash 26 again slash 26 and again 1 1 0 0 0 0 0 0 slash 26. So let me take the first one. The first number will be 0 and the last number will be 63. All right, the first octet will be 0 and 63. Obviously, I need 60 host for A. So I would like to assign this for A. Okay, this full block. Okay, I would like to assign it for A. All right. Next requirement is 28. It's enough that I need only 28. Even though I have 60 here, I need only 28. So I wish to split it into half. Okay. So let me put this into a half. All right. So to put it into a half, let me take this 1 0 0 0 0 0 0 0. Okay. So to put it into a half, I just take one more bit into, I put it into two portions, right? I put it into two portions. So just come next chart. I put it into two portions. So what I'm supposed to do is I have to borrow one bit. Okay. So when I borrow one bit, there are two portions which says 1 0 0 0 and the other portion is 1 0 1 0 0 0 0 0. All right. So this portion, the start is 64 and the end is 95. Okay, so how do I get 64? If I convert this number, okay, so this entire number, yeah. So this is 0 to 127. Sorry. By mistake, I've taken the wrong section. Okay. We are supposed to take this portion. So 0, 0, 0, 1. Okay. So 0, 1, 0, 0, 0, 0, 0, 0. Okay. So now I'm borrowing this part. Okay. So I'll get 0, 1, 1, 0, 0, 0, 0, 0. Okay. So now the first IP, if I convert this into decimal, the first IP is dot 64. So, and the new mask will be /27 because I have borrowed one more bit. Okay. And what will be the last IP? So 0, 1, 0, 1, 1, 1, 1, 1. So put all the host portion as 1, that will be the broadcast IP, right? So this is dot 95. That is what this block. So this block we will give it to B. Right? This block we will give it to B. So when we give this block to B, we understood that the remaining all portions, okay, so this is free, and this is free. So you were able to efficiently assign the IP address using VLSM. So what are some of the benefits of VLSM? You can take it down, right? So what are some of the benefits of VLSM is it allows the efficient usage of address space, okay? So it allows the efficient use of address space. Fine. And the second advantage is it uses multiple subnet mask length. All right. And you can have custom small address blocks are possible. Custom small address blocks are possible. So, and then you can even have a more flexible network design, right? So it allows for more flexible network design. All right. And then it also allows for hierarchical. Okay. So you can have hierarchy of hierarchical enterprise network. Okay, so that is possible. So this you usually will call it as classless subnetting. Okay, so this VLSM method of subnetting, usually we'll call it as classless method of subnetting. So now here when we talk about the protocols, so many protocols uses this VLSM or supports this VLSM like RIP version 2. All right, it supports VLSM. And then we talk about OSPF. Okay, these are all the routing protocols used in the network. Then protocols like EIGRP, then protocol like ISIS, and protocols like BGP. These all protocols supports the VLSM method. Fine. So we will discuss one more question with VLSM. Let us take say this is 25 host, and here it needs 120 host, and here it needs 60 host. Yes, we'll continue. Right. So you have 25, 120, and 60. Fine. So so we'll say what are the networks that we have. Say this is network A, right? This is network B. This is network C. And this is network D and E, right? So we'll say that A, the requirement is 120. B, the requirement is 25. C, the requirement is 60. D is 2 and E is 2. So now if the IP that is given to us is, let's say, 220.108.38.2.0/24. It's again a class C IP. So let us use the box method, which is entire box. All right. Now, what is the maximum requirement? It is 120. So in order to address the maximum requirement, obviously we have to borrow one bit. So let me expand the last octet dot 00000000. So I'll just borrow one bit and I'm splitting it into two. Right? So when I split it into two, I was able to get two blocks. Okay, so the first block, it starts with the IP 0 as a network address and 127 as the last broadcast address. Similarly, here it is 128 to 255. So already we have learned this in subnetting. Now the mask is, it becomes, the suffix becomes, or the prefix becomes /25. Okay, so /25. The subnet mask is nothing but 255.255.255.128. So this entire block, I just give it to A because the requirement of A is 120. The entire block, I just give it to A. And next, what is the next requirement? 60. All right. So in order to have 60, I wish to borrow one more bit. So this network is done. I'm not supposed to touch it. So there is one more called 10000000 in this. Okay, so I just borrow one more bit. All right. So when I borrow one more bit, this gets split into two. Okay, so how it gets split into two? 11000000/26. It has become /26, right? So again, when I borrow one bit, it's split into two. Okay, so this entire block is split into two. So now this is 128 and the last IP is 191 and this is 192 and this is 255. So how do I get these numbers? 128, 191, 192 by converting this into binary, so decimal. So convert this into decimal, you will get this 128. And when you put this as 10 and all 11111, you will get the last number. Okay, similarly, this is 192 to 255. So this block, that is /26 block, I wish to assign it to network C because that is the next block with highest requirement. Okay, fine. Next, what are we going to do is, so again, I'm going to split the third block into two. Okay, this one I'm just going to put it into two chunks so that I'll get at least 30 IPs. So already here there are 60 IPs, here again 60 IPs. So I'll put it into two, right? So how do I put it into two? Borrow one more bit. Okay, in this IP you borrow one more bit. So this will become /1111. 10.0.0.0.0/27. Okay. So when I borrow one more, so this block, all right, by borrowing one bit, this block I wish to give it to B. Okay, this entire block I have given to B. Okay, which is 223 and this is 224. Fine. So let us take this block. All right, so already 3 bits are there for the network portion, but the remaining I need only 2 bits. Okay, so 2 bits means it is enough that in the host portion I have this 2 bits. Okay, in the 2 bit in the host portion. So what I'm going to do is I'm going to chunk the last portion. I'm going to borrow all these 3 bits. I'll put it in the network portion. So in the entire block வந்து அப்படியே 8 பிரிச்சிடலாம் நம்ம. ஏன்னா 3 bits we are borrowing, right? So I'll divide into 8. Okay, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. I'll split the last block into 8 blocks so that this I'll give it to D, this I'll give it to E, and the remaining all is saved. Okay, these all portions are saved portions. All right, so only for my network requirement, this is done. Hope you all understand how the VLSM is done. So starting from the page number of 14, you could see the same technique is applied using circles, right? So here I have used box method. The same thing, it is represented using circles. And then starting from there are, these are the different methods used to solve the VLSM questions, right? And then starting from the page number 24, it is solved using VLSM chart. Okay, so the procedure is same, but only the method is different. And all the methods also is very similar to that of the box method. Okay, and then you could see some practical questions also. Right, so now what you all are supposed to do is, this is a qualitative assessment. You can solve these questions and you can submit it as a qualitative assessment, right? Fine, now we will see practically how this VLSM can be assigned to a using packet tracer to a real network. Okay, we'll see how we can assign it to a real network, right? So all of you can open your packet tracer. So we'll take this example 220.108.38.0/24. Okay, so as we could see here in the packet tracer, we'll take a PT router. So there are 3 routers in the network. So we'll keep 3 routers, right? And then let us have switches. And then we'll connect those networks together. Also, we'll have 3 PCs. Right. So now, as per our table, okay, so our topology table, we understood that this is a biggest network with, let's say, network A, all right, and it is assigned with 220.108.38.0/25, right? So this network is assigned with /25, all right. And similarly, the next biggest network is this. So I say this is network B, and it is assigned with 220.108 dot 38.128/26. All right. So this is the next biggest network that we have assigned. All right. And then the next biggest network is this one. All right. So we say that it is network C, and we have assigned 220.108.38.192/27. Right. And we have two more small network D, which is 220.108.30.224/30. And again, we have one more network, that is network E, 220.108.30.228/30. All right. So these are all the networks IP that we have given as per the VLSM chart. Okay. So already we have done the VLSM chart. So let's come here to this PC. So as per the requirement, what is the IP that we are supposed to give? So we'll give the first IP 220.108.30.2. So usually we'll do it. So the custom subnet mask is 255.255.255.0, but we have subnetted it, so we should give the mask for /25. So I give the mask as 128, and the default subnet mask, I just have it as 220.108.30.1. Fine. So we have completed assigning the IP address for this network. So let us come to this router. So when we click this router, so we'll make sure that the interfaces are shown to us. So to preferences, I say always show port label so that I could see the interfaces. So now interfaces is shown. Here it is. So I just go to the CLI and no en config t interface FA0/0. So I say IP address 220.108.30.1 and with the mask of 255.255.255.128. All right. Then I give a no shut. So this side of IP assignment is done. So if we hover our mouse over the PC, we could see that the IP is set with /25. And now coming on to this interface, it is 224/30 means only two IPs are possible. So it is 225 and 226. All right. So this side I wish to assign 225. This side, that is interface serial 2/0 IP address 220.108.30.225, and the mask is /30 means the mask is 255.255.255.252. Okay, so because only 2 bits are left in the host portion, we have 252. Okay, and there is a clock also, so we have to set the clock rate as 64,000. Okay, and say no shut. So this side is done. Right, so let us come to the router 0, this part of the router. So this part of the router, let us go to the first interface. En config t interface serial 2/0. So IP address 220.108.30. This side we assign 225, right? So that side we are supposed to assign 226, and the mask is 255.255.255.252. Okay, so no clock symbol, so I just give a no shut. So that part of the network is up. Similarly, we'll come to this part, interface serial 3/0. So this is 228 network, right? So 228 network. So I wish to assign IP address 220.108.30.228 means the network address is 228. So you will have 229 and 230. So I wish to assign 229 here. 255.255.255.252. Okay, and clock symbol. So clock rate 64000 and give a no shut. All right. So that interface is done. We'll come to the fast Ethernet interface 0/0. That network is, let's say, what is that network? So it is 192/27. So 192/27 is IP address 220.108.30 dot, right, 30 dot, sorry, fine. So I've given the address as 38, it is 30. Everywhere we are giving is 30, right? So we'll give the first IP 193. So 27 means the mask is 255.255.255.224. All right, and give a no shut. So we'll put an end and save it. So the router configuration here is done, right? So say this as 30. Similarly, this also. See, this is 30. Fine. Right. So we'll come to the PC. So to the desktop IP config. So here we assign 220.108.30.193. Sorry, 193 is already assigned, so 194. And by default, it shows the class C mask. It is 224. And the subnet mask is 220. Sorry, the default gateway is 220.108.30.193. Okay, fine. So this is done. So IP configuration, if you hover your mouse over the router, you understand that both the interfaces are assigned with /30 and one of the fast Ethernet interface, it is assigned with /27. Fine. Similarly, we can assign the IP for this router as well. Okay, so we come to this router, go to CLI and I say no, en config t. All right. So here it says interface serial 2/0. Okay, IP address 220.108.30.229 is assigned. So this should be 230. Okay, 230, 255.255.255.252. Okay, and give a no shut. All right. Similarly, interface FA0/0 IP address. So this site /26. So /26 means IP address 220.108.30.129. Let's say the first IP I am assigning for the default gateway 255.255.255./26 is 192. Right? So 192. So give a no shut. The interface is up. So let's come to the PC here and we'll go to the desktop IP assignment. We'll give 220.108.30.130. So already 129 is assigned, so 130. The mask should be changed 192, 220.108.30.129. All right. So IP assignment has been completed in all the routers. So you see this is a 30.1 and 30.225. Two networks are available. Here there are three networks available. And here again there are two networks attached. Fine. So if we examine the routing table. So let us examine the routing table of this router. So the routing table also very clearly says how it is subnetted. The variable subnet masking is very clearly shown in the router. All right. So it's saying that I know only three networks. All right. So the other two networks is not known to me. Okay. The routing table very clearly says what are the networks. Now we'll configure the routing protocol so that every network is reachable to every other network. So we'll just open this router, and to this router, it is understood that only 2 networks are known. The other 3 networks is unknown. So we have to tell this router about the other 3 networks. So let us just open it, and I'll just go to the CLI and give an end WR config T. So we'll say that router RIP, we'll go for RIP version 2. All right. So, and what is the command? Version 2. All right. RIP version 2. And we are going to tell about the directly connected networks. Okay. So what are the directly connected networks to this router? Network 220.108.38.0. Okay. So that was a directly connected network. And then you say network 220.108.38.224. This was a second network connected. So I just say an end and write. Okay, save it. Similarly, let me come to the middle router. So here again, we just say config T router RIP version 2, because it is all subnetted, variably subnetted. You can't use version 1, which will not understand what it is, right? So network 220.108.38.192. This was the first network connected to this router. Okay, similarly, network 220.108.30.224. So once again. So the IP that we have configured is all 30, but the network that I've given is 38, right? So I need to do a small change here. So we'll do it one more time. Okay, so I'm sorry for the mistake. Router RIP version 2, network 220.108.30.0, the first one. Similarly, 30.224, the second one. Okay, so right. And we'll come here again. So we'll rub whatever we did in the previous one. No network 220.108.38.192. So no network will remove it. Fine. So now we'll give it network 220.108.30.192. Okay. Similarly 30.224. Similarly 30.228. Right. So end. Right. So to this router again, we'll just come here. So router RIP version 2. All right. So then say network 220.108.30.228. Similarly 30.128. Right. So we have given all the configuration. So we'll check the routing table. We'll come to the router. Now in the routing table, you could understand it has learned all the routes. Okay, so 30.0/25 is there. 26 is there, 27 is there, and 30 is also there. All right. And now if you enable ping, okay, if you establish a ping, it will do a ping, right? So this will work. So this is how you have to configure the VLSM, and you have to do it in the routing in the packet tracer. Suppose if you are doing a VLSM topology and you are doing it in a packet tracer, it's better that you write it down first on a note and then you take it up. Fine. So with this, we come to a conclusion of this class. So what is expected out of the class is